When we look at a crashing ocean wave, our human eyes instantly see a beautiful, vibrant blue color. But a computer looking at that same scene doesn't really see the water or the waves at all. In many ways, computers are actually blind to the pictures we show them. That's why we use artificial intelligence. For this unit, we can think of AI as a system that takes in raw facts and figures, or data, to perform tasks that usually require a human brain. To understand how it works, we have to look much closer. If you zoom all the way into a digital image, the smooth shapes disappear, and the whole picture breaks apart into a rigid grid. You'll see that the solid wave is actually made up of thousands of tiny, individual colored blocks. While our eyes naturally stitch those blocks together to make sense of the world, an AI's reality starts by looking at each of those blocks as a separate piece of information. We call each one of those tiny blocks a pixel. Pixels are the building blocks of every digital image, and they provide the data that an AI uses to perceive color. Every pixel combines three light channels: red, green, and blue, or RGB. We give each channel a number from 0 to 255. For example, if we set red to 255 while keeping green and blue at 0, we get a solid red square. This is the heart of AI perception. The machine doesn't see the color red. It only recognizes the exact mathematical recipe of those RGB numbers. But just having a pile of numbers isn't enough. The AI needs a way to figure out what those numbers are actually telling it. To make sense of the data, the AI uses a process called representation and reasoning. Think of it like the AI's thinking phase. It uses internal rules to turn those raw numbers into a decision we can understand. We can see this in rule-based AI. We use if-else blocks to give the computer a specific test. For instance, we can tell the system, if the red value is higher than 200, while green and blue are both low, then label the color as red. The data enters the system, passes the test, and triggers the correct answer. By setting up these clear mathematical boundaries, we give the machine a reliable way to turn abstract numbers into an intelligent choice. Writing these rules by hand works for basic colors, but it's almost impossible for a person to write a custom if-else rule for every single shade of color in the world. Instead, we can use learning from labeled examples. We give the AI thousands of digital flashcards that have been labeled by humans and ask the computer to study them. On this graph, you can see how the AI organizes what it learns. By looking at all the examples labeled green, the AI finds mathematical patterns on its own and groups them together. But there is a risk. If a human accidentally labels a bunch of blue pixels as red before the AI studies them, that bad data confuses the system and ruins its ability to make good predictions. We call this garbage in, garbage out. If we give the AI bad training material, we're going to get bad results. Remember, an AI doesn't have common sense. Its intelligence depends entirely on the quality and accuracy of the data we provide. For AI to be helpful in the real world, it can't just be hidden math. It needs to be easy for people to use. We want using technology to feel as easy and obvious as flipping a light switch. This is natural interaction, the goal of making complex systems simple enough for anyone to use. Think about pushing a slider up and down with your hand. That simple movement is a natural way for a person to give the AI the input it needs to start processing. Great technology bridges the gap between our human intuition and the computer's strict mathematical logic. You're going to practice this by building your own AI color detector in Scratch. First, you'll create variables for red, green, and blue. You'll turn them into sliders and wire them into your if-else blocks. Next, you'll set the limits of those sliders from 0 to 255. This ensures your project follows the same rules as real pixel data. Finally, you'll snap your if-else blocks together. Now, when you move the sliders, the computer tests the numbers and instantly predicts the color you've created. What you've built is a complete loop. You provide the input, the rules handle the processing, and the computer gives you the output. Just remember, AI perceives our world as raw data. It works by finding mathematical patterns within that data, and it uses those patterns and rules to make intelligent decisions. AI isn't magic, it's just logic, and now that you know how it works, you have the power to build it yourself.